Yeah, I'm doing fine right now, okay? You say. Whatever you say. Sure. Okay. Whatever you say, puppy. Okay. Sure. So many windows. It's not very healthy. Okay, whatever. Position. Base. Time dot delta time. Okay, let's forward back. Left times base speed times time to time. What are you trying to get? You want a napkin to clean the floor? What did you do to the floor? What did you do to the floor, though? You gotta tell me what you did to the floor so I can give you the napkin. What did you do to the floor so that I can give you the napkin? When? I understand you want to clean it, but you have to tell me what you did to the floor so I can give you the napkin. Why is it so hard to do that right? Right. Okay, what did you do to the floor that you're asking me for a napkin is my question. All right, hold on. I'm going to help you in a second. Hold on. Hold on. God, really? Another damn stupid thing? Guess what? Ban. Love banning people. Stupid stuff. Okay, let's see. This, not this. Okay. Save? Nope, I didn't save. Yeah, that I think it causes the same problem. It feels like it moves faster when you're inputting multiple things. That's fine. Okay. Let's see this guy's vid.
Position, well, with this vector 3.right, but we don't just add vector 3.right. We multiply it by our move speed and by this magical time.delta time. And this is really kind of where all the magic comes from. Time.delta time is the amount of time in seconds since the last update was called, or since the last frame was called. So what this is going to do is smooth out this movement so that we move 2 meters.
I should probably be doing this on. In general, what's this guy's name? Thing about this is I get to see ads. Personal one. Ish.
Running.
Hey, what's up? I'm Jay. This is going to be true as long as we're holding it, and we'll add the position, well, with this vector 3.right, but we don't just add vector 3.right. We multiply it by our move speed and by this magical time.delta time. And this is really kind of where all the magic comes from. Time.delta time is the amount of time in seconds since the last update was called, or since the last frame was called. So what this is going to do is smooth out this movement so that we move 2 meters once per second. This update will be called so many times per second, maybe it's 60 times a second, whatever that number of times a second is. Over the period of 1 second, the delta time will have added up to 1. So imagine it was just 4 frames. Say we ran at 4 frames a second and each frame was at 0.25. We would do a quarter of it the first frame, a quarter of the movement the second frame, a quarter of it third, and a quarter of it fourth frame. Eventually we would make it the full 2 meters. So this is actually our meters per second in movement speed. So all we do is multiply those and we get the value and it moves nice and smoothly. Now let's talk about rotating, because our current setup really only allows us to move an object in this one world position, and if our camera adjusts, well, we don't have lined up movement anymore. So how do we do that? Well, let's disable this script, and I'm going to enable my move transform position with input smoothly and rotate.
Another one. Create new C# script with rotation. Match that to the player. I think I need a point start.
We'll start moving around, and here I'm using WASD to move, and Q allows me to rotate along with E. So I'll hit Q and then hit W, and check it out. Now I'm able to rotate and turn. Now let's see what it looked like on the previous one. If I go check this other box and I've already rotated and I hit my arrow keys, Notice that I still move in world space. In fact, I can actually enable both of these because I've bound them to different keys. I can use my arrows to move in world space and my WASD to move in local space and rotate and control that.
That's a lot of stuff.
We get the value and it moves nice and smoothly. Now let's talk about rotating, because our current setup really only allows us to move an object in this one world position, and if our camera adjusts, well, we don't have lined up movement anymore. So how do we do that? Well, let's disable this script, and I'm going to enable my move transform position with input smoothly and rotation. We'll start moving around, and here I'm using WASD to move, and Q allows me to rotate along with E. So I'll hit Q and then hit W, and check it out. Now I'm able to rotate and turn. Now let's see what it looked like on the previous one. If I go check this other box and I've already rotated and I hit my arrow keys, notice that I still move in world space. In fact, I can actually enable both of these because I've bound them to different keys. I can use my arrows to move in world space and my WASD to move in local space and rotate and control that. Very interesting movement. So let's check out how this script works and how we're able to do the rotation-based movement, because that's usually what we want. We usually don't want to just move in world space unless we have a fixed camera that's never changing. All right, let's go open this up. And our move transform.
The object relates to its forward or right vector. Does that account for object's rotation? Okay, so input, get key, transform.rotate, tell me at the time, turn speed vector 3 down. Vector 3 down. Oh, because vector 3 up and down change the x-axis? The y-axis. Interesting. So that's different. I didn't expect that. Let's create 2 serialized fields here. Great serialized fields, sir. Sub 2, but let's do 2F for now. Shit open.
Form position with input smoothly and rotation script has 2 serialized fields. We have a move speed for our movement in meters per second and a turn speed for just how fast we're going to rotate. Here you'll see that we have a lot of the same code that we had in the previous section for our movement, but I've bound them to D, A, W, and S, or WASD. And our D key is going to move to the right, so we just take delta time times move speed, and here we don't.
So he's not using a vector 3 anymore, he's using a transform right. Because it's vector 3 would move it within world space, this would move it within its local position.
Don't use vector 3.right. This is the big difference. If we want to move local to our object or our transform and not world space, we can just use transform.right to do that instead of vector 3.right, which will give us the world space movement. The other thing that we need to note is there isn't a transform.left, but negative transform.right is the same as left. And then we get...
Okay. So, let me see here. Let's do the movement first. With oops. Input. Get key. Code. Dot W. Transform. Dot position. God, I did it right this time. Speed times time. Transform dot position. Transform. Actually, negative transform. Forward. God damn it. Delta Jesus. Code. That's the upper. Transform dot position. Delta time. Position. Negative transfer. This is within its own, so it's not world space. With rotation. And I've already had one of those. Oops. Zero puts it in the ground. rotation. And he used Q and E. I'm going to use the mouse. Just keeps having this. Okay. So this is movement. This will be rotation. Axis is mouse. Up down because that's the y-axis, which is what you're trying to turn. So if
Get up.
input hit axis.
Can you get up? Go play with your toys.
What's he doing?
Elijah, please go. What happened? Why isn't mommy putting up in storm? Is there a reason for that? I'm pretty sure there is. Oh, so no. No, you can't. Oh, now it's Blippy. Before it was Evan Storm, now it's Blippy. What do you want to watch? You want to watch Evan Storm? Are you sure? So if I put Evan Storm, you're not going to come back and ask me to change it again, are you? Are you sure? Because it almost sounds like you will. Okay, you're gonna watch it, right? You're not gonna ask me to change it, correct?
Today on Evan Storm.
Oh, okay, no, we're not doing that. Okay, I'm gonna put Evan Storm, but don't ask me to change it. 'Cause I'm not going to. If you would do this.
Today on Evan.
Yay. Love that it's only showing up on one of my ears. That's weird. What? That's so something that I just realized. He did is rotate. That's adding. Getting the mouse input Y. So to get this to work, I might have to do this differently. Rotate 0. What? Oh, it's causing some power outages. Engine speed times time dot delta time. Work because might have to do this is transform dot rotate here without. It's not an if statement. This will be an actual. Mouse Y. T. I'm sure I can do this. Get access. Why? Mouse what is this? Transform dot rotate. Google, stop listening. Properly? guess I can new vector it. So it's new vector it. 3. There we go. Patience, this is gonna see everything I missed. Here. Here. Oh, yes. Right now, it's moving, but sensitivity is not high enough. OBS was supposed to move. I should just change this to crap. Now, it's trying to rotate itself, but it's encountering a problem. See the Y changing. Close to the ground. I can change that. Let's do this as well. Y equals the book at x mouse y, translate and rotate. Move it through mouse y, mouse sensitivity. It's time by delta t. Every frame it's calling the mouse y input. Not that I can think of. Damn. The y is changing. But let's just change this to axis. I think that's the problem, but delegate axis mouse y. Transform by rotating new vector 3 0 0 mouse y. This is obviously not what he was trying to show. I'm getting some rotation here. Just not much. Don't know why. This changes to like 1,000. Something really stupid. it's still not altering the rotation. Good. Yeah, now it's 37, but well, I'm gonna edit this or comment this out. But let's do what he did. QD. Let's make another serialized field into turn speed, and we will use these to move it. Float. If down. Wait, no, he just put get key. Key code. Q. Transform dot rotate. Can you write it again? That rotates. Turn speed and a vector 3. Okay. See it goes. Turn speed times. Down goes down on the Y. Know what I'm going to do. Vector 3 up. Speed. This should make us want to hit Q and E.
Turn speed modifier, I can go like this. Get to like 100. See how fast that goes? Yeah. That would be like turret control right there. Well, I would like to be mouse.
Get the same for forward. We have transform.forward and negative transform.forward to go backwards. The other part that's new here is the rotation. So Q is set to turn me to the left. So I call transform.rotate and we pass in time.delta time and arc turn speed, or we multiply this value times that. And then we use vector3.down because I want to rotate in the negative direction on the y-axis. And if I go into Unity and I just look at this, if I just drag this down, I can see the value going down means left and value going up means right. Good way to test if you're just kind of getting mixed up and not sure. You know, just go in, drag these values around and see what happens.
Another ad. Nope, I can't watch this with this guy. Oh, man.
2 meters once per second. This update will be called so many times per second, maybe it's 60 times a second, whatever that number of times a second is, over the period of 1 second, the delta time will have added up to 1. So imagine it was just 1. We usually don't want to just move in world space unless we have a fixed camera that's never changing. All right, let's go open this up. And our move transform position with input smoothly and rotation script has 2 serialized fields. We have a move speed for our movement in meters per second and a turn speed for just how fast we're going to rotate. Here you'll see that we have a lot of forward and negative transform.forward to go backwards. What? The other part that's new here.
What? No. We talked about this. Remember? What did I say? I wasn't going to change it. Now you want to watch Mario? Really? Elijah, come on, man. We're not doing this, dude. No. You're not changing every 5 seconds what you want to watch. I'm sorry that I changed to Blippi. That was my fault. But it should be on Evan Storm now, and that's what you wanted to watch. I'm not changing it anymore. Well, I'm sorry, but that's what you asked to watch, dude. Oh, I'm sorry. We can turn it off. Do you want me to turn it off? Okay, well then you need to watch what's on there, dude. I'm sorry.
Here is the rotation. So Q is set to turn me to the left. So I call transform.rotate and we pass in time.delta time and arc turn speed, or we multiply this value times that. And then we use vector3.down because I want to rotate in the negative direction on the y-axis. And if I go into Unity and I just look at this,
come on,
just
man.
drag this
Stop
down,
doing that.
I can see the value going down means left and value going up means right. Good way to test if you're just kind of getting mixed up and not sure. You can always just go in, drag these values around and see what happens.
Right. Moving objects using a rigid body.
Now we'll talk about rigid body movement. This is a very common type of movement used to control objects that need to respond to physics. Here I've set up a cube that we can move around using its rigid body component. I've added a rigid body to it, have not changed any of the default settings, and we've added this move with force script. It has
force. That's different. Okay. So let's see. I already know how this works. So I already know how this works. Let's move to C# script. Call it move. Let's do that. Move with. How do you spell move?
has a movement force value of 10, and you can kind of see how the object bounces around. Now let's look at our move with force class. It has a rigid body component that we are caching in the awake method. In our awake, it's just an expression body method because there's only one line, so it's only doing one thing. We say rigid body equals get component rigid body. So that's just going to get a reference to this rigid body component so that we can tell it to add force later. So in our awake, we do that. We also have this serialized field for our movement force, which is going to control how much force we add to the object as we hold the key down. Now this will need to be relative to the mass value set on the rigid body. As the mass goes up, we need more force to move the object around. The next thing we have is a fixed update method, and this is different from our update method. Generally, when we add force to a rigid body or a lot of physics objects or doing a lot of physics related things in general, we want to do them in the fixed update. Definitely adding force to a rigid body though we want to use in our fixed update step. The fixed update is very much like the update with a tiny little bit of difference. It's where all the physics work is actually done, and it has a special priority so that it can run at its own special frame rate and that we can have our physics be a lot more reliable and not fall apart when our frame rate falls apart. So we need to do this in fixed update. If we do it from update, it will give us some issues. And
yeah, because update is frame rate dependent. Fixed update is not tied to frame rate.
You'll notice them where we get 2 force calls in one frame, and suddenly one frame we get a little boost or a little extra stutter. In fact, if you change this code and you go from fixed update to update, you should be able to replicate and see that negative behavior, that problem where it starts bouncing around a little bit and it isn't as smooth. Now let's take a look at how it actually works. On line 13, we just check to see if the W key is being held down with input.getKey. So if we're holding W, it's true. And then if we are, we add force to the rigid body, giving it our movement force multiplier and vector 3.forward. So this is going to move along that Z axis. It's going to add to the Z axis. And it's just going to make our object kind of push in that direction, which on our cube is kind of making that weird rolling action, which I think is kind of cool. Now let's look at how we can make a cube move around in a...
Oh. If we do... This is the thing that as far as I know, private void is the same as not making it public. It's in the single line. I don't need to do this. We're assigning rigid body to the name rigid body. Get component dot dot. Component taking, well, they're taking rigid body. Starting. And then fixed update, here's where we do math. So if input dot get key, in it. Okay. Well, I'm just coding today, so. But I'm just coding today, apparently. I'm in a coding mood. Spell code. If we're pushing down W, we're going to take the rigid body. To add force. Load force times direction, which in this case would be vector 3 dot forward. Similar to if you put that get key. S rigid going so hard. Movement times for 3 back. But add force. This is add force within a specific vector. Would be movement force times transform. No, that would be it. We add force. Figure out this. Body. The one that I wanted to watch the most because let's see how that goes. No, okay. Never know. Yay! Of course, the camera would be unusable in this instance, and it's because I have it as a child at the player cube, but I'm trying to figure out a way for it to follow the X and Y without doing anything else. That's the most interesting to me, and there's a reason for that. Anyway, okay, let me see here. Go back to this. Okay.
So this is going to move along that z-axis. It's going to add to the z-axis, and it's just going to make our object kind of push in that direction, which on our cube is kind of making that weird rolling action, which I think is kind of cool. Now let's look at how we can make a cube move around in a more natural fashion, more like a character. Have it maybe slide and bounce into walls and stop. So to do that, we have a move with force use transform rotation script. I'm gonna hit play and show you what that does if we only turn this script on. So I hit play and I roll forward. It's not doing what I wanted, and I can roll to the left. Can't go left anymore. Now if I hit forward, I go a different direction. This is all because the forward direction of my object is getting out of whack. So let's take a look at that. If I look at my blue value right there, forward is actually pushing down, and I believe right is gonna push that way. So I hold right and I go that way. Now forward is pushing left. So if I hold forward, it's actually gonna roll to my left. Not the behavior that our player would want. Really, really confusing. So how do we fix this? Well, if I reset this transform position and I check the freeze rotation boxes here, suddenly I can move a little bit. If I hold the two together, I can move, but I'm no longer getting that rolling behavior. So why can't I move anymore? It's because there's not enough force to actually give me a slide. So
under rigid body constraints. I can't overcome the friction unless I do wee. If I overcome frictions start going fast. Damn. Let's do 15. There's acceleration. I'm getting the hang of it.
So I'm going to crank this force up to 20. And now I can kind of slide around. So you can see I'm able to slide. I still can't quite turn. So how do I add in some turning? I'm going to add in another script, and then we're going to go take a look at both of these scripts together. So we're
Scale. Big floor now. Okay. Two back here. Decent speed here. I don't have to clip this plane, but you know, it's probably because the plane is spot. Let's go down. I gotta remember to use the right keys for that. Wow. Now I wonder what happens if I switch this to make it a cube, a sphere rather than a cube. Create 3D object sphere. Let's reset this to 0, 0. Where am I putting this? At 1. Sphere at 1. Sphere. I'm going to attach the move with physics. I'm going to turn off move with physics. Oh, rigid body. That might help. Rigid body. I don't actually want to. Yeah. If I freeze rotation, it won't spin like I want it to. So let's turn off your rigid body. Let's turn off fuse gravity. Let's see. Interestingly enough, this is not causing me any issues. Even though what happens if I do this? I mean, it slides around, but it's definitely not as what I want to do. Interesting. Interesting.
We're going to add in this rotate with mouse script. Now, if I put my mouse over the game view, I can turn it, and I can hit W, and look, it moves in the forward direction. I just hit A there to go sideways, D to go left, go back with S, and W, and I can just kind of rotate all around and drive like a crazy man and bump into boxes and not go through them. So now I have some limited physics-based movement. Let's take a look at those scripts and see how they actually work. First, I want to look at the force use transform rotation one.
Here. Oh, shit. Go back. Let's see what's different. So rather than using a vector 3, because this is world space movement, he's using a transform. Okay, so rigid, add force, movement, force times transform. Yeah. Okay, so instead of using vector 3s, he's using a transform movement. Okay. Get it. It's pretty much the same code. Still creating a rigid body class rigid body. He's still adding a movement force float. He's still getting the component rigid body and assigning it to the rigid body name in the awake function. The only thing that's changed is that instead of movement force times vector, it's movement force times transform. Okay. She made a rotation script, which is where I want to see the puppets here. So let's make a different one with physics. C# script. Understand why. Still adding that to the player cube. The sphere, we're going to do that, and we're going to let's see out of the way. Player cube. So it's the same as the move with force. The only thing that's different is we're using the transform rather than the vector 3. So we don't need a void start. We do need to declare rigid body. So private rigid body. Serialized. I love how I can do that without having to do this. And somehow it still works. Force equals a value. That all correctly. Single line, so I don't need you to add this. Thank you. Away. Still don't know what this particular thing does. So, assigning this to this component. Close it. Let's update. So it does tell me to change it to private void. Now my question is why? Based on recent edits. So it doesn't tell me. This function is called every fixed frame rate frame. The one over here is labeled. Okay, but my question is, why is this wrong? Show potential void. Change it to private, but where's the difference there? Why do I need to instead do it as a private? Already private, as far as I know. Okay. So if input E code W. Make the rigid body. We're going to add a force. With a value of speed or movement force times its direction, which would be transform dot that's easily enough to understand. So if input key S is pushed, I'm going to check the rigid body, force, this value times the direction dot back. There's no back, that's right, it's negative forward. Forward. Okay. If parameters. Right, transform right. Fight. Yes. Stop fight. Good job, Dum Dum. Okay. So this is the same thing. Now, how does it behave different? Okay, so in the rigid body, I'm gonna put gravity back in, and we're gonna keep the rotation the same. So it drops. Force is not great enough. Oh, this will make it so that even if I rotate, it still moves at the transforms. Okay, so this is okay. I get it. I get it. I know what's going on now. So
Here we've got a public class, move with force use transform rotation, and we cache the rigid body in our awake method on line 9 so that we can use that later to add force. And we have our movement force variable that we can adjust the speed with. And remember here we had to crank it up to 20 because when we're not rolling over, we actually need a little bit more force to get over the friction to be able to slide along the ground. In our fixed update, we check to see if the W key is held. If it is, then we add the force. Really nothing different here from our previous one except for using transform.forward. So just like in our transform position movement, if you saw that, we use the transform related vectors, our transform forward and our transform right. Here we use transform forward, transform right. And again, we use the negative values to give us back and left. In our rotate with mouse script, we have a turn speed so we can adjust how fast our player can.
the one I needed to see. Rotate with mouse. So turn speed, this would be like the mouse sensitivity. Oh, it's not a float. So he's not putting this in as a float, he's putting it in as a integer. Horizontal. So horizontal times turn speed. Okay, and then vector up. This makes world. This new. I've never seen this before. Attach that to the player cube. Actually attached. Okay, I did. Okay, rotate with mouse. This up a budget body. Open it. Still made a serialized field. That's pretty standard. So serialized. Load. I like to cross mouse. It's to use 3. I don't think that's going to be enough. It's a float. It's still a float. So I wonder what the issue is there. Is it a friction issue? Variable horizontal. This axis. So let's say it was the mouse. It's no. Then he told it to go to the transform. Rotation on the x-axis. The x-axis is going to be based on This is where it's different. So I would normally do transform.rotate X, Y, Z. He's doing just X and then space.
Turn. And then we have an update method which gets the axis value for mouse X, which is actually a float. Let's just spell that out. It's just
So it is a float. Okay. So I was confused there for a second, but it is a float. I was right. Huh.
a number, and it's going to be positive or negative, some small number. Then we call transform.rotate. We pass in the horizontal value, which is just that mouse X value. This is again how fast we've slid the mouse left or right. Or how far we've slid it left or right. The turn speed, we multiply it by, and then vector3.up, because that's a 1 on the y-axis. So we're just rotating on the y-axis, and we're using world space to do that rotation.
That's what that is. So you're taking the value of the mouse times the sensitivity, and then in the direction of y, because you're spinning in the y-axis, right? And assigning that rotation based on world space. So that is different. That's something that's I never thought of doing. So rotate top of float times our mouse sensitivity times a new vector 3 up. This is a different kind of function I've never used, or a different kind of way of scripting. So now, oh wow, look at that! That is kind of fast. Let me see. Mouse sensitivity. Let's do 2. Actually, let's do 1. That's 1 to 1. See my song play. Six. Oh, wow, look. Yeah. See? Let's see. I didn't change this movement force factor? Thought I did. Yeah, I did. Wait, what's the dealio? Using transform rotation. Using transform rotation. Private float movement force is 20. 20 to reset this value. Oh, okay. It was considered changed by this. Okay. Oh, geez. Bye. Alrighty. So, oh, I'm still maximized on play. Fuck. No. Right. Don't maximize on play. Let's see. Let's see how this looks. Okay, so I can spin around. Oh, yes. Oh, God! Since there's no friction from the ground, I just freaking launched. Okay, sphere, rigid body. This uses gravity. Funny how that's not falling to the ground. Why is it not? Let's see. Okay, technically it is. So I want to push. Bye. Okay, now, if I don't freeze the flare cube, rigid body. Okay, I'm not going to freeze the rotations. I want to see what happens. Okay, so I drop to the ground. Oh, see here, I would have to move in world space because I'm moving based on the transform. That looks hilarious. This is. Oh, man. Just $1. Huh. Yeah, if I don't freeze the rotations, because I'm using the transform, this, it wouldn't work. But if I use this one, let me see. Moving world space, right? Let's see. So make this 20. Yeah, this oh geez, it doesn't matter where the camera's pointing. Bye. So this rotates it, but it doesn't manage the camera per se. So how would I do that? I would want it to move forward based off where the camera is pointing. I would have to figure that out later, but yeah, that's hilarious. Okay, so rotate with mouse script, move forward with, okay, and then we're going to freeze rotation.
So we're just rotating on the y-axis, and we're using world space to do that rotation. Now let's take a look at jumping. How would we implement a jump with this? Well, we can turn on our jump script, hit play, see what it looks like, and then go take a look at the code. So here I've got it. I can move around and I can hit space and jump and kind of bounce around. Whoa, and now I just jumped kind of wildly. Now I'm gonna turn off the rotate with mouse one. I'm gonna go to move with force and see what that looks like with jump. So I got, oh, and turn off the freeze rotation options. So now I should be able to kind of like roll around and do a weird bouncy jump. And let's get the scene view and game view together so we can get a nice big view of what that looks like. And kind of kind of jump around and do some interesting, weird behavior. I'm not sure what use it is yet, but I think it could be fun. Let's take a look at the jump script and see how that ties in and how that works with these other two scripts. So if I expand it out, you'll see that we have a jump force set to 300.
Okay. Alrighty. Why do you keep asking me to save? Oh, son, it's not to save. It's supposed to. Here, test. There, you happy? You can control save when I hit control save? Yes, good. That's just the scene. You name the scene test. God damn it. Where'd the thing go? Oh, here it is. This jump force. I'm guessing he's adding a force in the direction up. But it's based on world space, up in world space rather than up based on the transform. That's what I'm feeling here. Let me see. Okay, let's do a new script. I'll just jump. Let me see if I can figure it out before he tells me. So let's see, under fixed update, because it's physics, he's adding force. So private void fixed update, and let's create a serialized field as well. So serialized field for jump force. Jump force. Jump force. Oh, I gotta declare it as a float. Oops. Private. That's how you spell private. Float. No. There we go. Private float. Jump force is 100. This is a private fixed update. We are going to see if input get key space, get key down space. We're going to take the rigid body and add a force with that value and the direction of up. Okay, so if get key down. Code. That's not how you do that. Code. Space. Space. And we're going to. Oh, I have to do the rigid body declaration. Rigid body called rigid body, and we're calling it on awake and putting the okay. So rigid body, rigid body. Wake. Awake. Do this. Need any of that. Set it to is that the body is equal to get component dot rigid body. If that, we're going to the body force. It's going to be force force times vector 3 up. Yes, maybe. Let me see if I got this right. This is how I learn, by experimenting myself. Okay, let's let it do its thing. Okay, now player cube. You have the rotate. Okay, we need to add the JavaScript. JavaScript. You do. Okay. Oh, you know what? Let's put the rigid body above all the scripts. Nuts. Okay. So now save. Okay. I can't do it on a fixed update. Right now, it's asking under fixed update. This has to be different. I think under update I need to get the key code, and then under fixed update I need to do this because it's not behaving the way I expected it to. Let me see. 300. Save. If that and is, I know there's an is grounded. I don't know how to call it though. I'll have to figure that out later. It only works when it wants to. And that's because I'm pushing it outside of its fixed. Okay, so it would have to be. Okay, I wanted to figure this out before he does it. So void. If just not rewriting it, I know. Dot get key down. Decode space to call jump. Here, rather than having this, I don't know if I can do this. all this jump brackets. I don't know if I can. Now vocal memory jump cannot be used like a method. Why? Void jump. Yeah, what's wrong here? Oh, I need to close it. Locked within here, but I don't want it to be locked within here. Let me see how he did it. I mean, I got it to work, but it's
And
causing
I'll
me
open
shit.
the script up and
Okay, here we go. So private rigid body. Shoot. Public class. Jump. Private rigid body. Rigid body serialized. Okay, jump force probable. Oh, here we go. He's doing something different. He made a public pool. Private void awake. I think this is so that you can tell if he's grounded or not. Reading get key down in fixed update is unreliable. Reading get key down in fixed update is unreliable. It's possible for 2 updates have passed before a fixed update call, which could lead to missing the get key down. Example, update number 1, user press space. Update number 2, user still holding space. Fixed update, get key down is false, which is why we don't read get key down in fixed update. Note, get key returns true for every frame and would still be fine to use. But in this case, we don't want to add force every frame, they hold space. So in private void update, we're doing if should jump is not false, then should jump equals input get key down space. Private void if should jump, then you're gonna okay.
And we can take a look at the jump class. It has a rigid body that we cache and awake, very similar to a lot of the other scripts that we've had. And then it has a jump force with a value set to 300 and this Boolean value called should jump, which is either going to be true or false. It'll be false by default. And then I have a big note about why we have this should jump and why we have an update.
So if it's false by default, this turns it to true. No, because it's not checking. You're checking here if it's not false. You're checking if it is false. If should jump is false, then should jump should equal that. And if should jump equals that, and set it back to false. That way you can only push it once? Is that what this is doing? It's a different way of doing that. did everything else. So he created a rigid body, he created a serialized float for the force. He just created a new private pool here. Clear the private pool, should jump. Okay, if I had the right idea, I just had the wrong execution. Jump. Jump equal to dot get e down e code space. Okay, so we're declaring it as false. If it's false, then we're going to say it's going to equal to this. Fixed update. If jump, so if it's true, do this function, and we're gonna set should jump to it's a different way of doing that I did not expect. This allows me to keep on pushing it. So I need to find out. I know there's a grounded command, I just don't remember what it's called. Is grounded check unity. Update is no. I want to do it's a little different though. Hmm. I experiment. Sometimes even experimenting, I can't figure it out.
Jump force with a value set to 300 and this Boolean value called should jump, which is either going to be true or false. It'll be false by default. And then I have a big note about why we have this should jump and why we have an update and a fixed update. Because you might think, well, in our update, we'll just read and see if they press the key, then we do a jump and we add some force in the up direction. Or maybe we'll read it in the fixed update. The problem is very well spelled out here, I hope, in the description or the comments that you can download this code and go look at yourself, is that it's possible for us to miss a space call. So it's possible that we hit space and the player doesn't actually jump if we put everything into our fixed update. So if we change this to say something like this, I'm going to copy it and paste it. If we didn't have this, I'm going to comment this out with Control K, Control C. If we had it just like this, it's possible that the user presses space, we run an update, get key down is already processed, and it does.
I gotta learn how to do that. Hold on. Control K, Control C. Huh. Oh. How do I uncomment? The quick key for commenting is Control K, Control C. I don't know how to uncomment. I'm sure he'll say it again.
It's already returned true for that update. Then we run another frame. Fixed update hasn't run yet because fixed update doesn't necessarily run with every update frame. So we run another update and the user is still holding space. So get key would return true, but get key down no longer returns true. And then our fixed update calls and get key down is returning false, and we've missed that jump. So this is why we read our input in update and then we act on it in fixed update when it comes to these get key down type events. If it was just a get key, I'm going to hit Control Z twice to undo that, by the way. But if it was just a get key check, so it wasn't a get key down and it was for every frame, it would be totally fine. That's why we can do that for our movement, but for our jumping, we don't want to do that, and we want to separate this out and really spell out the issue there. Now let's have a little fun and see what this all looks like when we change our object from a cube to a sphere. So I've got a rigid body based sphere / ball, and I'm going to turn it on and hit play. You're going to see a little bit of magic, and then we're going to talk about how it's working. So hit play, and I'm not going to touch the keyboard, and look at that, my ball is just kind of bouncing around, and it just keeps bouncing. Now I'm hitting the keyboard to move it around a little bit, and you can see that the cube actually moves with it too. So if I move, I get the ball bouncing and moving and the cube moving. I'm going to ignore the cube though and just control that ball. So why is this ball so bouncy and wiggly, and how am I making this happen? It's actually a side effect of this Sphere Collider's material. So a lot of time people don't notice this, but the colliders actually have a material option. If I go to my box collider, I could set it here as well. And we can just add in a physics material, and it'll adjust the way that the object responds to physics and collisions. If I select my bouncy one, you can see that I have my bounciness set to 1, which is the maximum. 0 to 1 is 0% to 100% essentially. And I've turned down the frictions all the way to 0. I also set friction combined to average, so that if it bounces and combines with something else that has little friction, it'll average the two out, and bounce combined to maximum, so it'll always be the maximum bounciness. That's a way to allow you to have multiple physics surfaces combine and do what they should do. Here I just really want it to be super bouncy. Now how do we create one of those? We just right click in the project view, go to create, and choose physics material. Where's that at? Right there. Choose physics material. You can name it, create your own, give it your own settings, and play with them as much as you want. Add them to the two objects that are bouncing and colliding. Try it out and play around. It's a lot of fun, and it gives you some really interesting gameplay options. Now let's take a look at controlling a character. Here we've set up a capsule for our character. So
let me clean up this thing. So Control S. Let's X out of that. Save all these. We're gonna X out of that. Let's do new project 3D. Character test. Open up and do its thing. Oh man, that's taking forever. Come on. Alright, well that was that. I'm gonna be right back. I gotta pee. I should probably change desktops when I do this. Okay, so main camera. Or not. Plane. Change its add new not lens flare. Let's call it wow. There we go. Brown. And I'm going to attach that to my plane. Now that plane is brown. So that plane should probably be reset to 0, 0. And let's do 5 and 5. Nice big plane. Oh, jeez. Okay.
So we just create a capsule with game object, 3D object, and capsule. I've added a rigid body and frozen the rotations. And then we have the jump script that we've used previously. It just adds force in the upward direction, and the rotate with mouse that reads our mouse X and then spins our transform rotation. So let's take a look at this. We can move, we can jump, we can kind of bounce into things or bump into things at least. I can't really walk up those steps, but I can kind of jump up here. Let's see what the script looks like, what this code looks like, and how it works. Here we have another move with force use transform rotation script, but it all
maximum velocity. Right. You're assigning the rigid body. The rigid body's velocity. It doesn't. That's the clamp. This is the clamp, I guess.
also has a
So you could download the code. So I don't.
clamp velocity feature on it. And if you look at line 14, we're just checking to see if our velocity for our rigid body has approached or gone above our maximum velocity. And if it has, we just stop adding force. So this is kind of a soft cap where we're gonna get to around 10. We'll go maybe a little bit over, stay kind of right around that level. We won't hard cap at exactly 10 though and stay there. But it stops us from going too fast. In our previous one, if we don't have this, eventually our cube or our character can just keep building up velocity and speed and get out of control. So here we have a way to control it and make it a little bit more like a player movement. So that's why when I hold down W, it doesn't ever actually just take off and get faster and faster and faster to the point where I'm going out of control. One question I get all the time is, should I use a character controller or a rigid body? What's the difference? Why do they both exist? Well, a character controller is really just kind of an extension of a rigid body. It does a lot of the things a rigid body does, and then a couple more things that characters generally want to do, like being able to walk up slopes and control gravity a little bit more individually, or give some extra, I guess, tight control over an object without scripting too much of it. More character level controls. So let's see what a character controller setup looks like. Here I've created a capsule and added a character controller to it. I've added my rotate with mouse script that just reads that X movement and spins us around. And then I have a character simple move script. I'm going to expand it out and show that it has a move speed and it is grounded. That isn't an option we check. This is just to kind of show what it's doing. So I'm going to hit play. We'll take a look at how this moves and then talk about it. So I turn, I run around, and you can see I kind of slide along that a little bit smoothly. It's a bit smoother than my default physics rigid body setup that I had. So when I had a character that was moving with a rigid body, it doesn't get that same smooth sliding. I also can just kind of walk up these slopes. Look at that, I can get up there, I can kind of run up there. It's a little bit small, but I can get up there at least. And if I had my jump, I'd be able to jump up there as well. And I move over here and just fall down. Let's take a look at the character controller settings now. So we have a slope limit that adjusts how tight of a ramp we can walk up. And we have a step offset, which adjusts how big of a step I can take. So I can go up to here. I can't make that last step, but if I turn up my step offset a little bit more, there we go, now I can step up there. And if I turn it up even higher, like to a 1, not 11, like a 1, I can even step up onto this block here. So slope is again for the incline. If I wanted to just crank it up and be able to walk up something that's more than 45 degrees, I could turn that up. And the step is for going up those actual stairs. The radius and height you can see in here. So if I go select my character and just start adjusting my radius of the character controller. You can see it moves, and that's what it's using for the physics to control the character. It doesn't use the actual capsule collider. And then the height. So if I crank this up, you see my character is much taller. Sometimes our radius and capsules, or radius and height, don't necessarily match our character exactly. We want to get them as close as possible, but sometimes we need to do some weird stuff. Like you may even have a character controller that's down low and a thing that's kind of flying above, like a hovering bird, with a character controller part that's moving around is controlled down lower, or the whole body or something. So let's take a look at this code. We have our character simple move script. Character simple move caches our character controller in a way.
Character controller called character controller. It's grounded. When awake, you're caching the character controller into main character controller. Fixed update, float horizontal input, get access horizontal, float vertical input, get access vertical. Three direction. Movement. I guess these are part of the character controller. Direction and movement. Like transform direction. Where's he? Declaring these? Is he declaring this as direction and assigning this? Get your movement transform direction.
And then it has this public bool is grounded, that again is just so that we can see it in the editor, and we'll talk about that after we look at this code. Then we have a fixed update method. And the fixed update, we read the horizontal and vertical axes into these two floating values. These are actually set up in edit and then project settings and input. So here's the input manager, and I've expanded out horizontal, and you can see that the left and right, or A and D keys, control the horizontal, and if I expand out vertical, it's down and up, or S and W. There's also another horizontal and vertical down here, by the way, and if you look at this, the difference here is that this is set to joystick axis. So this is actually going to read from game pads or controllers, where this one is going to read from key or mouse. And it can be a little bit confusing because you can kind of set up keys and button names that don't really map to things, right? So you might think that if you didn't have this one, it would still work. It won't. You need to have both of these in here if you want to be able to read from the keyboard and the controller. They're actually separate. That's why there are duplicates. It's intentional, but a little bit confusing. I understand that. All right, so let's go back into our code. We read those two floating point values that are either going to be 0 or a value between -1 and +1. So it'll be positive if I go up or right, and negative if I go down or left on my controller. And then we give a new direction, or we create a new direction, a vector3 named direction, by passing in the horizontal for the X and the vertical for the Z. We create a movement vector, and we do that calling the transform.transform direction. And this is kind of where that magic comes in, that's making it map to world space or local space, where it actually controls our character, and we can have the camera snapped behind him instead of moving around in world space. So instead of using like a world transform, we're creating this local transform here. And that's all this is. This movement transform direction just takes a world position like forward and converts it to my local forward. And multiply that by move speed, and then we call character controller.simpleMove. I'm going to add a space here. Character controller.simpleMove returns back whether or not the character is grounded, which means whether or not the character is on the ground. So we call simplemove, we give it our movement amount that we want to move, and we just get back whether or not it's on the ground. We're not doing anything with that, we're just kind of putting it into the editor because I wanted to show that we can read that and we can use it.
Here is getting a little bit more difficult because he's calling and naming a new vector3 called direction. He's calling and naming a new vector3 called movement. That's equaling a transform dot transform direction. Now, the one thing I didn't see was whether or not he snapped the camera to the collider. Let me see. 3D object capsule. Let's call this player. Player. Let's do a camera. Player. Damn it. Player. Camera. Okay, here, let's add component. Character controller. We still need a new script. Movement. Push it to the player. Okay. The thing that bothers me about this, it doesn't seem to have physics. And that's the thing I was finding before.
If we need to. So let's take a look at it. I'm going to go in here.
But you still have to move script. No, I'm not seeing a capsule collider.
Here, I'm going to go back to my game view and I've got my character selected and I just want you to look at the is grounded part. So let's change the height back here to 1, or what was it, 1.8. There we go. Now watch the is grounded value. If I go up here, I'm still grounded. You can see there's a little bit of a period where it drops, and if I drop off the edge, a little spot where I'm not on the ground. And we can use this to control things like jumping on a player. So if we
That's the thing. I don't want to just copy code. I want to know what the code means. How you spell force, sir? Let's. This should be. New credit is here. Thank you. Don't do that. So a character controller named character controller. I'm gonna public. Okay, now we're not doing a start call. Here he didn't do a private void awake. He just did a void awake. Which leads me to believe that, like I thought, it's not necessary. Character controller. Set it to get component. Character. Controller. Funny enough. Funny how that works. Still gonna keep the void update because I'm gonna need the jump inputs. There's some floats. Axis. Another float named Hawk. Dot get X this vertical. Declaring a new vector 3. Pulling that vector 3 direction. Assigning it the value of new vector 3 horizontal, or in my case strafe. No value there. Yeah. Vector 3 called movement. I will call you vector 3 called movement. Declaring it as transform. Transform direction. Here we're calling character controller dot simple move from move. Like I get that it works, but I want to know how it works. It just works motto don't work. I don't like it. And now I can offset the camera to make it follow behind. I don't know why it does that. Why I can't just open it with the other Visual Studio. Like, why do you have to make a whole new one? I don't want a whole new one. Here. Let's see. Jump. If should jump is equal to false, then set should jump to that. The problem here is I am not getting the that doesn't have a rigid body. As far as I know, you need a rigid body to create a force vector. Unless I do transform.translate up. My key code is down, so I should only do it once. Let's see. If rounded, then I don't need any of this because I'm not running it in fixed void. I'm not doing it in physics. So why is this in here? Because we're not using forces. I guess it kind of is, isn't it? But get key down decode space and is grounded. Translate new vector 3. Transform position. X. Now, of course. Transform position Z. Let's make this. It's translating, not setting the position, I think. Also, this is the wrong node. And find out. Okay. Setting Y to 1, but I'm already at 1, so that's not working. So, oh, it's translating to that height, so that wouldn't work. I would have to institute a force, but this doesn't have a rigid body. So how do I do it? Walk. This would be just a jump force, whatever it would be. I could just, this is setting it to 2. It's not actually set. Are you still at 300? That's not, no. And forces 2. it's not actually working with physics. It's just putting me up there and then moving me back. So this would not work. Okay, so as much as I would have wanted, that's not working.
Is whether or not the character is on the ground. So we call simple move, we give it our movement amount that we want to move, and we just get back whether or not it's on the ground. We're not doing anything with that, we're just kind of putting it into the editor because I wanted to show that we can read that and we can use it if we need to. So let's take a look at it. I'm going to go in here, I'm going to go back to my game view, and I've got my character selected, and I just want you to look at the is grounded part. So let's change the height back here to 1, or what was it, 1.8. There we go. Now watch the is grounded value. If I go up here, I'm still grounded. You can see there's a little bit of a period where it drops, and if I drop off the edge, a little spot where I'm not on the ground. And we can use this to control things like jumping on a player. So if we want to have a player that jumps, then we don't want them necessarily jumping when they're not grounded. If we have a character controller set up, we can just read that and tell whether or not they're on the ground. In fact, let's go do that now. Here I've set up a character with the rotate with mouse.
I can do it that I just thought about, rather than this, it would be whatever yeah, I did this wrong. So transform dot position y plus jump force. This is very long. Probably very inefficient. So whatever that position is, plus 2. But I think that the character controller does weird stuff with gravity, so it's not great. Yeah, see? I mean, it works in the same vein that now made and no 3D object. Camera's still not locked behind it. That's too high. What the fuck? I think I'm biting off a little bit more than I should be chewing.
Script and my character move script so that I can turn, rotate, and do this nice little jump action. So I can jump up on these cubes, bounce around like a weirdo, and have some fun. I also wanted to note though that the main camera is just a child of this object, and that's how it's following it around. So if I go to the main camera, hit F, you see that it's just a child with an offset here, kind of aimed down there. So as I move my thing around, it just kind of follows me nice and tightly. So I can jump. Now let's go take a look at the
I kind of figured that, but I didn't want to fuck with it.
character moves.
Yeah. now it's inside the but position have to do the mouse look. Haven't done that yet. I got the jump. Sense. Times horizontal in space world. work for this. Bye. If I wanted to, that would have to happen on the camera though, not on the. Wish it would stop doing that. Oh fuck! I closed it up. Get the axis of it, and then rotate it using this. Float. Input. Get axis. Yeah, by accident every time I try to hit back. Delete. Vector 3 dots. All right. Times. Um, Oh yeah? Lock the rotations. I see that. Yep.
Yeah, and I have one too.
Okay.
That's hot and a ball.
That freezes the axis. What captures the axis without?
Script. Well, first let's note that we have a move speed, a jump speed, and a gravity, something that we haven't had in previous scripts. I'm going to open this up and take a peek at it. We have an awake that caches our character controller, and then we have a move direction that we're keeping up here, this vector 3. I'm going to get rid of the private keyword because it's a little bit of extra noise we don't need there. So we have this move direction, and then we have a fixed update. Our fixed update reads our horizontal and vertical axes. We get an input direction vector that we create from our horizontal and vertical, giving them to the X and the Z. We transform that into our local objects transform, so our forward will be forward for our object. And then we take that transform direction and we're putting it into this vector 3 called flat movement. And you'll see why in just a moment. That is the move speed times our time.delta time for our fixed update, because in a move call, which is not going to be the same as the simple move call, we actually need to take into account time and delta time. The move call, or the simple move call that we have here, we don't need to pass in that delta time. It's going to be kind of automatically figured out for us. We also can't pass in a Y value. We can't go up and down with simple move. Move is going to allow us to do all of that, but it also makes us put in the extra work of handling that stuff. So we're taking our transform direction, multiplying it by delta time and our move speed, and that gives us our move direction. But our move direction isn't exactly the flat movement. It's the flat movement's X and Z values and the current move direction's Y value. So we're keeping this vector around every frame, and the Y value is being controlled completely independent of our input. So our input for horizontal and vertical are only controlling the Z and the X, and the Y is controlled some other way. In fact, you'll see how it's controlled 2 lines down. So how do we control it? Well, we check here on line 25. If the player jumped, then move direction.y is set to our jump speed, which I think I've set to 0.5. Else, so if they didn't jump this frame and they're grounded, then we just set their move direction to 0. So if the character controller is on the ground, move direction 0, we don't need to push them down at all. Now, is grounded is also a check on the character controller. So I'd mentioned that we can use the simple moves return value to see if it's grounded. We can also just read the is grounded property on the character controller at any time to see if it's on the ground. And then the final thing we do if we're not jumping and we're not grounded is apply some gravity by subtracting gravity times delta time from our move direction. So we just keep applying gravity every frame. This value gets lower and lower and we fall faster and faster. And then we finalize it with character controller.move and pass in that move direction to make our character actually do the movement. The final thing I want to take a quick peek at is our player jumped, which just checks to see if the character is grounded and they pressed space. So this little check right here makes sure that they are already grounded. We can't jump if we're not grounded. And that's how it works. Gives us a nice simple.
Not nice and simple. Alright. I like this tutorial, but
Simple character.
I am going to take a break.